we have 3 and 0. So for the Cartesian equation, we'll basically convert these two equations to t in terms of x and t in terms of y. So in this case we have t equals 1/3 of x, and then t will also be equal to y minus 2 over -2. So when we combine those two equations together, we have 1/3 of x equals negative y minus 2 over 2. So we have negative 3 over 2x equals y minus 2. And then we will just have y equals negative 2 over 3x plus 2. And this will be the Cartesian equation. And then when we put this into a calculator, the x1t will be 3t. y1t will be 2 minus 2t. And then the interval will be t minimum 0, t maximum 1. The x minimum, let's say -10, -10, 5, -10, 10, sorry, so it should be +10, and 5. And then let's go to the graph. You can see it is just a straight line in the first quadrant. So it is proved to be correct since the slope is negative, and then it is smaller than 1, as we can see, and then +2, because when x equals 0, the y is above the origin. So yeah, so this is the answer we eventually got. We have initial point of 0, 2, terminal point of 3, 0, and Cartesian equation of y equals negative 2 over 3 x plus 2. Okay, now let's go to the second example. So say we have x represented by 2 cosine t, y represented by 2 sine t, and then the parameter interval is between 0 and 2 pi. So this time I want you to do it on your own. Find the initial point, terminal point, and Cartesian equation of the parametric equation with the help of a calculator. So I encourage you to pause the video and come up with a solution yourself. When you're finished, you can continue the video, and then we'll discuss the answer together to see if you did it correctly. Okay, it seems that you have found a solution. So now let's begin. So the initial point, we know that it occurs when t equals the left end of the interval. So when t equals 0, we have initial point x equals 2 cosine 0, which is just 2 times 1, which is 2. And then y is 2 sine t, which is 2 sine 0, which basically is 0. And then the terminal point, we have x equals 2 cosine 2 pi, which is also 2, and 2 sine 2 pi, which is also 0. And this time we will find it very difficult if we want to convert these two into t in terms of x and t in terms of y, because these two are trigonometric equations. So in this case, let's first put out our calculator. So let's input x1t, 2 cosine t. y1t will be 2 sine t. And then window, t minimum is 0, t maximum we have 2 pi. Sorry, 2 pi. 2 pi. And then x minimum, we'll keep the same window for x and y. Then let's graph it and see what it looks like. You can see it looks like a circle. You can see that it starts from the initial point and then it goes counterclockwise back to the same point, which is also its terminal point. So we know that the equation for circle is x squared plus y squared equals r squared. So in this case, x and y will be 2 cosine t squared plus 2 sine t squared. 2 sine t squared, which equals 4 cosine squared t plus sine squared t. Recall from the trigonometry, we know that cosine squared t plus sine squared t would just equals 1. So in this case, we'll have 4. So 4 is also equal to r squared. So r, we know that r will be equal to, r will be equal to 2. So we have the Cartesian equation x squared plus y squared equals 2 squared. So from the equation we can see that it represents a circle centered at the origin with a radius of 2. Okay, so that's about it. So that's the basis of parametrics. And for the next part of the video, we'll discuss parametrics more in terms of calculus, and then we'll go through more of the examples just to get familiar with the topics of parametrics in case that you might forget when you come back and then review all these concepts. So see you in the next part of the video.